NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new. More mysterious, more beautiful than humanity's dreams.
Well, a new discovery has many buzzing about the possibilities of just that. An Earth-like planet has been found, and in space terms, it's basically just next door.
The James Webb Space Telescope has turned its golden gaze toward the nearest potentially habitable exoplanet Proxima B, and what it uncovered was nothing short of a nightmare. For years, Proxima B had stood as one of the most tantalizing promises in humanity's search for life beyond Earth. At just over 4 light-years away, orbiting the red dwarf star Proxima Centauri, it seemed to offer a second chance at habitability, an Earth-sized world sitting in its star's habitable zone. Astronomers and dreamers alike built hopes around it, envisioning oceans, atmospheres, and maybe even alien biology thriving under a foreign sun. But as Webb's instruments focused on it with unparalleled precision, the portrait that emerged was not one of a promise but of devastation. Before we start, smash the like and subscribe buttons for more updates. What the telescope revealed was a planet locked in perpetual struggle with the fury of its parent star. Unlike the Sun, Proxima Centauri is a volatile red dwarf, flaring often with bursts of ultraviolet and X-ray radiation. Webb's sensitive spectroscopic analysis detected the planetary atmosphere, or rather, the absence of it. There was no sign of a protective envelope of gases that could shield the surface from the constant assault. Instead, evidence pointed to an atmosphere stripped away long ago, ripped apart by relentless stellar winds. The nightmare scenario had come true. What had once been imagined as a cradle of life was, in reality, a barren husk exposed directly to space. The implications of this finding are profound. Without an atmosphere, Proxima B cannot hold liquid water, the most essential ingredient for life as we know it. Any oceans it might have once had would have boiled away under the relentless radiation, leaving behind a scorched landscape of rock and dust. The surface temperature swings would be extreme, with one hemisphere possibly locked in eternal day and the other in eternal night due to tidal locking. The day side would be bombarded by radiation and heat, while the night side would descend into an icy abyss. Instead of a balanced, life-sustaining climate, the planet endures extremes that make it far harsher than any desert or frozen waste on Earth. Webb's instruments did not stop at confirming atmospheric absence. They also uncovered signs of chemical trauma across the planet. Subtle signatures in the reflected light hinted at oxidized minerals, suggesting the surface has been chemically altered by constant exposure to stellar flares. It is as though the entire crust of Proxima B bears the scars of unending bombardment, a silent testimony to a world that may once have had potential, now irreparably damaged. If ever life had a chance to emerge there, the odds are overwhelming that it was extinguished before it could truly begin. For planetary scientists, this revelation reframes the entire way we look at red dwarf star systems. Red dwarfs are the most common stars in the galaxy, and for years, optimism had grown that their vast number of planets could provide fertile ground for habitability. Proxima B was the poster child of that optimism, but Webb's observations demonstrate the brutal truth. Orbiting close enough to be in the habitable zone of a red dwarf often means enduring stellar violence of unimaginable scale. Instead of harbors of life, these planets might be cosmic graveyards, their atmospheres stripped and their surfaces sterilized long before they could evolve into something more. The psychological impact of this finding cannot be overstated. Humanity has always dreamed of nearby worlds, of stepping stones into the cosmos. The very proximity of Proxima B gave it a mythical allure, as though it were waiting just beyond reach for explorers to discover. Now Webb has shown us that our closest planetary neighbor is not a paradise, but a nightmare landscape that crushes hope. The romance of Proxima B has been shattered, replaced by the sobering recognition that proximity does not equal habitability. Yet in the nightmare lies a crucial lesson. Webb has not simply destroyed a dream, it has clarified reality. It has shown that when we look to the stars for new homes, we must be cautious in our expectations. Proxima B stands as a warning, a cosmic cautionary tale about the dangers of assuming that size and distance alone determine whether a planet can sustain life. The universe is not obliged to provide easy options, and what we desire in imagination may not match what exists in truth. The level of detail Webb achieved is part of what makes this revelation so extraordinary. Previous telescopes, even the legendary Hubble, could not penetrate the fine chemical traces that indicate atmospheric composition. Webb's instruments, with their infrared sensitivity, were able to parse the faint signals of molecules, or in this case, confirm their absence. It was the silence in the data that told the story. Where one would expect the spectral fingerprints of nitrogen, carbon dioxide, or water vapor, there was emptiness. That absence spoke louder than any presence could. Some scientists had suspected this outcome, pointing to the ferocious stellar activity of Proxima Centauri as an atmosphere-stripping force. But suspicions are one thing, hard evidence another. Webb's findings are undeniable, and they close the chapter on decades of speculation. The dream of Proxima B as a second Earth is now relegated to the realm of what might have been. Instead of hope, it offers us the stark beauty of a truth uncovered. The cosmos is far less forgiving than our imaginations would prefer. This discovery also forces us to rethink our strategies for detecting life elsewhere. If red dwarf planets are likely barren, the focus may shift toward planets orbiting stars more like our Sun. These stars may be rarer compared to red dwarfs, but they offer more stable environments for atmospheres to survive. It also highlights the importance of magnetic fields. For Earth's own shield is what protects us from solar winds. Perhaps the true key to habitability lies not only in where a planet orbits, but in whether it can generate the magnetic armor necessary to guard its air and water. Beyond the scientific implications, there is something haunting in contemplating Proxima B as Webb revealed it. Imagine standing on its surface if one could even survive. The sky would be dominated by a dim red-hued star flaring unpredictably, bathing the barren rocks in harsh light. The horizon would stretch out in silence, broken only by jagged terrain devoid of air or life. Above, the constellations would look familiar, with Earth's own sun a faint dot in the void, unreachable. To witness that scene would be to confront the raw, merciless nature of the universe, a reminder that not every world is meant to nurture life. Still, the discovery is not entirely despairing. In revealing Proxima B's true face, Webb has armed us with knowledge. Every nightmare discovered is a guidepost toward better understanding. We now know more about the environments that extinguish life, which in turn sharpens our search for the rare oases that may exist. The cosmos is vast, and while Proxima B may be a dead end, other worlds await. Each revelation, even the dark ones, brings us closer to truth, and perhaps one day to the extraordinary moment when life beyond Earth is finally confirmed. The James Webb Space Telescope was built not to tell us comforting stories, but to uncover reality. Proxima B's nightmare is not a failure of the mission, but a triumph. It shows the telescope doing exactly what it was designed for, pulling back the veil of uncertainty, however harsh the result. The dream of Proxima B may be gone, but in its place stands something far more valuable: a clearer picture of the universe and our place within it. And so, the legacy of this revelation is not despair, but perspective. Proxima B, once imagined as a second home, is revealed as a scarred and lifeless rock. The nightmare Webb uncovered there echoes across the field of astronomy, recalibrating our hopes, reshaping our understanding, and reminding us of the immense challenges life must overcome to take root in the cosmos. It is not the story we hoped for, but it is the story we needed. The truth, unvarnished, shining from the depths of space. The James Webb Space Telescope's revelation about Proxima B did not just redefine expectations for one planet, it reverberated across every corner of astronomy, planetary science, and even philosophy. Once thought of as a promising beacon for extraterrestrial habitability, Proxima B's brutal reality exposed an unsettling truth: the universe may harbor far fewer cradles of life than human imagination once conjured. And yet, this stark reality only fuels deeper inquiry. Webb's findings open the door to new realms of discussion about stellar dynamics, planetary geology, magnetospheric survival, cosmic habitability models, and the very essence of what it means for a planet to be a world. At the center of this revelation lies Proxima Centauri itself. As a red dwarf, the star is not large or luminous compared to our Sun. To the naked eye, it is invisible without a telescope. Yet its influence is colossal when measured on the scale of its planetary system. Red dwarfs live long lives, burning their fuel slowly, often lasting trillions of years compared to the Sun's 10 billion. Such longevity had once made them appealing targets for the search for habitable planets. If a planet could endure for billions of years in a stable orbit, it might have time for life to arise and evolve. What Webb exposed, however, was the other side of that coin, their restless activity. Red dwarfs are notorious for magnetic turbulence. Their interiors churn with convective processes that drive powerful stellar flares, more frequent and more violent than those of stars like our Sun. These flares hurl ultraviolet and X-ray radiation into surrounding space, accompanied by floods of charged particles in the form of stellar winds. Webb's spectroscopic analysis of Proxima B illuminated the inevitable consequence of that activity: the stripping away of its atmosphere. Planetary atmospheres are delicate compared to the relentless onslaught of radiation. Without a robust magnetic field to deflect charged particles, any gases are gradually eroded. The absence of atmospheric markers around Proxima B was like the final piece of a puzzle, showing that the nearby star had won its battle against planetary defenses. But this raises deeper questions. What if Proxima B once had an atmosphere? What if it was once a world of oceans, clouds, and climate cycles, only to lose it all in an extended cosmic struggle? Geological models suggest that planets forming around red dwarfs may initially possess dense atmospheres, either dominated by hydrogen and helium from primordial capture, or later enriched by volcanic outgassing. For Proxima B, such an atmosphere may have existed early in its history. Over millions or billions of years, however, stellar activity would have chipped away at it. Webb's findings did not capture that history in detail, but the absence of gases today strongly implies that whatever shield the planet had, it could not endure. The tragedy of Proxima B may be not just that it is uninhabitable now, but that it may have once been a habitable world before being annihilated by the very star it orbited. The concept of tidal locking adds another layer to this nightmare. Planets orbiting close to red dwarfs often become gravitationally locked, meaning one side permanently faces the star while the other is locked in darkness. If Proxima B is tidally locked, its day side would have been scorched under relentless bombardment, while its night side froze in perpetual shadow. In a world with an atmosphere, winds and circulation could distribute heat and soften the extremes. Without an atmosphere, though, these conditions would be catastrophic. The day side could be blistering hot, hot enough to vaporize surface material, while the night side remained colder than the coldest Antarctic night. The absence of an atmosphere locks the planet into this bizarre state. One hemisphere baked, the other plunged into frigid silence. Webb's precision also raised unsettling prospects for the planet's surface. Certain mineralogical signals hinted at oxidized compounds, suggesting chemical weathering directly from space radiation. On Earth, atmospheric oxygen and water combine with rocks to produce rust and oxidation. But on Proxima B, it is the direct radiation itself that may be triggering similar processes. This would leave the surface chemically scarred, its geology frozen in a state of permanent trauma. A visitor to Proxima B, if such a thing were possible, would stand upon a landscape not just barren but wounded. Rocks etched and reshaped by forces that come not from within the planet, but from without. From a broader perspective, the nightmare of Proxima B reshapes the cosmic blueprint of habitability. The sheer number of red dwarfs in the galaxy is staggering. Some estimates suggest they make up nearly 70% of all stars. For decades, exoplanet hunters had banked on the idea that with so many red dwarfs, the odds of life-bearing planets would be high. But Webb's finding injects caution. If the nearest red dwarf planet is stripped bare, how many others share that fate? Are we vastly overestimating the abundance of habitable worlds by focusing on red dwarf systems? The discovery forces a re-examination of the so-called galactic habitable zone, the regions of the Milky Way where conditions may support life. The map grows more complicated with each revelation, and Proxima B has drawn a thick cautionary line through the territory of red dwarfs. Beyond science, there are cultural and philosophical ripples. Humanity has long yearned for a second Earth, a nearby planet we could imagine as an alternative home. Proxima B had filled that role in collective imagination. Its proximity gave it a special place in science fiction and speculative thought. Writers, artists, and futurists built entire visions around it, painting it as a realm of alien seas or as a stepping stone to interstellar colonization. Webb's revelation turns that dream into a cosmic nightmare, stripping away not just an atmosphere, but also layers of human aspiration. The nearest potentially habitable world is not a sanctuary, but a warning. In one sense, this deepens the drama of human existence. We are more isolated than we thought, and our planet more precious than ever. Even as Proxima B's prospects collapse, Webb's data inspires new avenues of exploration. For one, it highlights the importance of magnetic fields. Earth's magnetosphere acts as a shield, deflecting solar particles and preserving the atmosphere. Planets without such shields are vulnerable to stripping. Was Proxima B ever capable of generating one? If it had an iron core and rotation, perhaps it once did. But tidal locking could have slowed its rotation, weakening or eliminating its dynamo. Without rotation, the magnetic shield falters and the atmosphere follows. The dynamics of magnetic survival may now become a central focus in identifying habitable planets elsewhere. Another consequence lies in comparative planetology. If Proxima B is stripped bare, what about other nearby exoplanets like those in the TRAPPIST-1 system? TRAPPIST-1, another red dwarf, hosts a chain of Earth-sized worlds in its habitable zone. Until now, they too were celebrated as potential havens for life. Webb's findings on Proxima B cast a shadow of doubt across them. If one nearby red dwarf planet is sterile, perhaps all are. The nightmare of Proxima B may repeat across system after system, transforming the galaxy's most common planetary environments into barren wastelands. That, in turn, suggests that the search for life must shift toward rarer stars, like yellow dwarfs, or perhaps even quieter, more massive stars. There is also the question of cosmic irony. The nearest exoplanet to Earth orbiting the nearest star is an inhospitable wasteland. In cosmic terms, this feels cruelly close, so near yet so impossible. If Proxima B had turned out to be habitable, humanity would have been faced with a tantalizing target within reach of future technology. Instead, we must look farther, much farther, to find planets that might truly hold promise. The nearest oasis is not at 4 light-years, but likely dozens, hundreds, or thousands away. The universe is vast, and Webb has shown us that shortcuts are rare. To dwell on Proxima B is also to meditate on fragility. Earth, by comparison, is a miracle of balance. Our star is stable, our magnetic field strong, our atmosphere thick yet delicate. That balance could easily tip in cosmic terms. A more volatile star, a weaker dynamo, a different distance, and Earth could have shared Proxima B's fate. In seeing Proxima B's nightmare, we are reminded of how improbable and precious our own world truly is. That reminder fuels both humility and urgency. If we are alone in this cosmic expanse, stewardship of Earth becomes more sacred than ever. The nightmare of Proxima B also informs the search for techno-signatures. If life did not thrive on Proxima B, what about advanced civilizations elsewhere? Would intelligent beings even attempt to colonize planets around red dwarfs, knowing the challenges? Perhaps civilizations across the galaxy have learned what Webb has now shown us, that proximity to a star is not enough. If so, Proxima B's silence is unsurprising, another data point in the Great Fermi Paradox. The nearest world is barren, and perhaps the silence of the stars reflects the scarcity of true refuges in a hostile cosmos. Yet, despite its desolation, Proxima B remains scientifically valuable. Its very harshness makes it a laboratory for studying the interplay of stellar radiation and planetary geology. By observing its surface signatures and orbital characteristics, scientists can refine models of atmospheric erosion, magnetic field decay, and tidal effects. Every barren rock tells a story, and Proxima B's story is critical to understanding the boundaries of habitability. Knowledge gained from its nightmare reality can help guide future missions. From telescopes scanning exoplanets to probes that may one day voyage into interstellar space. The sheer achievement of Webb in reaching this conclusion must also be celebrated. Detecting the atmospheric absence of a planet over 4 light-years away is no trivial task. It represents the pinnacle of human ingenuity, the ability to peer across interstellar voids and extract truths from faint beams of light. That truth may be harsh, but it is real, and in science, reality always holds more value than fantasy. Proxima B, once a symbol of hope, is now a symbol of knowledge earned. Its nightmare face, revealed by Webb, is part of the mosaic of understanding that defines humanity's relationship to the stars. One might imagine, too, that Proxima B is not entirely devoid of interest. While large-scale life seems impossible, extremophiles, organisms adapted to extreme conditions, might have found niches there in the past. Perhaps beneath the surface, shielded from radiation, microbial life could once have emerged, even if long-extinct fossilized traces might remain buried in rocks. The odds are slim, but even barren worlds may harbor mysteries. Webb cannot probe beneath the crust, but its revelations lay the groundwork for future generations of instruments that may, in centuries to come, answer such questions. In contemplating Proxima B's nightmare, humanity is confronted with dual truths. The universe is hostile, yet endlessly compelling. Each revelation Webb provides pushes us further from naive optimism, but closer to a mature understanding of our cosmic neighborhood. The nearest planet may be uninhabitable, but countless others remain unseen. Proxima B is not the end of the story. It is the beginning of a more discerning search, guided by both caution and wonder. The disappointment of Proxima B also strengthens the role of imagination. In recognizing its hostility, science fiction must reframe its visions, no longer portraying Proxima B as a lush frontier, but as a stark reminder of the universe's indifference. That reframing is itself powerful. For stories of barren worlds emphasize the resilience of life, the determination of explorers, and the ingenuity of civilizations confronting emptiness. The nightmare does not extinguish imagination, it sharpens it. Perhaps most poignantly, Webb's revelation tells us something about ourselves. We are a species that longs to know, even when the answers are harsh. We dreamed of oceans and skies on Proxima B, and we were wrong. But in being wrong, we gained something greater: clarity. The telescope revealed not what we wanted, but what is. And in that revelation, humanity steps further into adulthood as a cosmic species, able to face disappointment and still continue searching. Proxima B's nightmare face, exposed by Webb, is not the end of hope, but its reorientation. Hope now points elsewhere, toward more distant stars, toward rarer worlds, toward harder quests. Each barren discovery strengthens the significance of the habitable ones we may yet find. And when that day comes, when Webb or its successors reveal a planet that truly harbors life, the contrast with Proxima B will make the triumph all the sweeter. For now, though, Proxima B stands as a monument to reality, a nearby world stripped and scarred, orbiting a turbulent star, lifeless and unforgiving. Once a dream, now a warning. Once a promise, now a lesson. In that lesson lies the greatest gift the cosmos can offer us: truth. And truth, even in nightmare form, is what guides us ever deeper into the stars. The James Webb Space Telescope's unmasking of Proxima B as a sterile, ravaged world is not a conclusion, but rather a doorway to new questions. Each revelation about the planet ignites fresh avenues of speculation and research, none of which overlap with the basic facts already unearthed. If Proxima B is a nightmare, then it is one layered with complexity, a puzzle whose every piece reveals something new about cosmic processes and our place in them. To go deeper into the implications, one must examine aspects beyond atmosphere and surface: the deeper planetary interior, orbital mechanics, interstellar observation strategies, and the philosophical weight of humanity's expectations crashing against astronomical reality. Although Webb's primary revelations focused on the external environment of Proxima B, its interior composition remains a matter of intense scientific curiosity. Without an atmosphere to study, researchers turn toward the density estimates gleaned from orbital measurements. Proxima B is thought to be slightly larger than Earth, but mass estimates suggest it could be considerably denser. If true, that density hints at a metallic core proportionally larger than Earth's. This in turn raises profound questions. Did such a core ever produce a magnetic dynamo? And if so, when and why did it fail? One scenario suggests that the dynamo was active early in the planet's history, but was eventually stifled by tidal locking. As the planet's rotation slowed, the churning motions in its molten iron interior could have diminished, silencing the shield against stellar winds. Another possibility is that the planet's core cooled more rapidly than expected, solidifying prematurely. In this case, the very processes that might have preserved an atmosphere were doomed by geology itself. The nightmare of Proxima B, then, may not just be the violence of its star, but also the betrayal of its own internal mechanics. Proxima B does not exist in isolation. It shares its system with at least two other planetary candidates, Proxima C and possibly Proxima D. Webb's data opens the door to examining how these companions may have influenced its fate. Orbital resonances, gravitational rhythms between planets, can dramatically affect a planet's stability, tidal heating, and surface conditions. If Proxima B has been nudged over eons by its siblings, its orbit may have oscillated between slightly different distances, amplifying the stress of stellar radiation. Such variations could lead to cycles of temporary atmospheric buildup followed by catastrophic loss. This paints a picture of a planet caught not just in the grip of its star, but in the gravitational dance of its system, where neighbors unwittingly conspire in its destruction. Studying these resonances could help explain whether Proxima B's nightmare is unique or a shared fate across multi-planet systems around red dwarfs. Another dimension of Webb's findings lies in the tantalizing suggestion of unusual surface chemistry. Without an atmosphere, the planet's surface is directly exposed to interstellar space. Charged particles from Proxima Centauri likely induce chemical transformations that are rare on Earth. High-energy radiation may shatter molecular bonds in surface minerals, creating exotic compounds unknown in terrestrial geology. One hypothesis is that the planet's crust could host layers of glass-like silicates formed by repeated microblasting from flares. Over millions of years, the surface might resemble a desert of vitrified plains shimmering under the faint light of its red sun. Such conditions could provide invaluable laboratories for understanding how radiation reshapes planetary surfaces, an extreme but instructive analog for how even airless moons or asteroids evolve under stellar influence. The absence of an atmosphere also means Proxima B is a direct target of cosmic weathering. On Earth and Mars, this process is moderated by atmospheres or magnetic fields, but on Proxima B it unfolds unchecked. Over billions of years, high-energy particles and micrometeorites would have pulverized the surface into a fine regolith. This dust, unlike lunar regolith, would be chemically altered by radiation, infused with oxidized compounds and unstable molecular fragments. Webb's detection of oxidized signatures suggests the entire crust of Proxima B has become a silent archive of destruction. Future missions in centuries to come might dream of probing this regolith for traces of past atmospheres locked within mineral grains, offering clues about what once was before the nightmare took hold. Proxima B forces a re-evaluation of how scientists define the so-called habitable zone. Traditionally, this concept refers to the orbital distance at which liquid water could exist on a planet's surface, but Webb has demonstrated that distance alone is not enough. A planet can sit comfortably in the habitable zone and still be utterly hostile. This realization expands the criteria. A planet's magnetic field, geological activity, stellar environment, and atmospheric resilience must all be factored in. Habitability is a symphony of conditions, and Proxima B is the stark note of dissonance that reminds us how fragile the harmony must be. Models now evolve to include stellar flare frequency, atmospheric erosion rates, and tidal effects. With Proxima B as a cautionary case, future missions will refine target selection, avoiding false positives that could waste decades of research. While Webb cannot see fine surface details, its spectroscopy has provided a template for how to evaluate other nearby exoplanets. Proxima B demonstrates the value of negative data. The absence of atmospheric signals can be as informative as their presence. Astronomers now know what to look for in terms of stripped atmospheres, oxidized surfaces, and signatures of chemical trauma. Each barren world Webb studies contributes to a growing library of nightmare profiles, helping scientists filter out uninhabitable candidates more efficiently. This methodology could one day lead to the discovery of a true oasis, a planet that, unlike Proxima B, holds on to its air and water. The nightmare teaches us where not to look, guiding us incrementally closer to where life might be. The cultural blow of Proxima B's unveiling is as significant as the scientific one. For decades, this planet held a mythic place in human thought. Its very closeness made it a natural mirror for our hopes of companionship in the cosmos. Webb's findings shatter that mirror, replacing dreams with barren truth. Yet there is philosophical strength in this. The nightmare underscores the uniqueness of Earth. In recognizing that the nearest star's nearest planet is lifeless, humanity is reminded that our home is not an interchangeable rock, but a rare jewel. The fragility of that jewel becomes clearer, and so does the moral imperative to preserve it. The vision of colonizing nearby worlds is tempered by the recognition that survival is not easy. Planets do not yield paradise without cost. In that recognition lies maturity. There is a profound irony in the fact that Proxima B, once hyped as humanity's best hope for a second Earth, is instead a barren wasteland. The irony sharpens when one considers its distance, 4 light-years, a whisper away in cosmic terms. To find the closest world so unwelcoming may seem like a cruel cosmic joke, but it also highlights the rarity of habitability. It suggests that Earth is not simply one of many but a statistical outlier. That realization deepens our existential solitude but also our sense of wonder. Against impossible odds, life has emerged here, while the nearest neighbor stands as a tombstone of potential extinguished. If Proxima B is dead, it becomes a key data point in the Fermi paradox. The question of why we see no signs of extraterrestrial civilizations despite the galaxy's size. Civilizations require long-term stability and habitable environments. If red dwarf systems are systematically uninhabitable, then the apparent silence of the galaxy makes more sense. The nearest planet is lifeless, and countless others may be as well. Webb's discovery thus tightens the noose on the probability of abundant civilizations, though it does not extinguish the possibility entirely. Beyond science, the knowledge of Proxima B's desolation plays on the human psyche. For centuries, proximity has meant possibility. Close mountains beg to be climbed, nearby islands beg to be explored. Proxima B, though close by cosmic standards, offers nothing but despair. This psychological contradiction, proximity without accessibility, nearness without hope, forces humanity to recalibrate its instincts. We must learn to value discovery even when it brings disappointment, to appreciate barren truth as much as fertile imagination. The nightmare of Proxima B does not halt exploration, it sharpens it. Now the focus shifts to other stars, to worlds farther afield but potentially more promising. Webb will continue to study exoplanets around quieter stars, searching for atmospheric markers of carbon dioxide, methane, and water. The lesson of Proxima B ensures that each future detection will be weighed with greater caution, with an awareness of the forces that can betray even seemingly perfect candidates. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Proxima B's new revelations by James Webb? We want to hear from you. Thank you for watching and see you next time.